Hello, good morning to everyone for this scientific seminar of our synergy team of the NanoBubble project. I'm very happy to introduce the team, and sorry, I have things coming up in my screen that should not come up in this way, but this is part of the niceties of online seminars. So once again, thanks to everybody who is participating in the seminar. It's my pleasure as head of the scientific department of ERC to introduce our guests and a little bit the background of this seminar. We have here three researchers of this synergy project. Raphael Levy, who is a physicist and has been working on biological application of nanoparticles for many years, 20 years, mainly at the University of Liverpool, and then became professor of physics at the University Sorbonne in Paris. So we have physics and truly European parcours. We also have Frédéric Bourdignon, who is a linguistic and academic librarian by training, and also for 10 years has been working on scholarly communication in the field of high performance sport, and then at the École des Ponts and engineering. She is in charge of bibliometric indicators and researchers at the LISIC laboratory in the field of science and technology studies. So that's a quite different field. We have physics, linguistics, and science and technology studies, but that's not all. We have also Y.J. Erdens, who has a PhD in philosophy of language, but has been working at the intersection of several disciplines, philosophy, science, and technology studies since 2008, and is assistant professor of philosophy at the University of Twente, having worked in several UK universities, including St Mary's, and has been project of other projects, including the Siena Ethical Guidance for Research with a Potential for Human Enhancement, which is in the EC Guidance now on identifying serious public ethics issues. So we also have a very important contribution from the ethical point of view, and we know that at ERC we take science extremely serious with our scientific evaluation and all that goes with it. And we also have ethics review and take ethics also very seriously. So that's another interesting part of this outfit of our synergy team and project. I will not say much of the project. NanoBubble focuses on how, when, and why science fails to correct itself, and it takes the field of nanobiology to see how that happened. Of course, that can then be extended to other fields. I think I will not say more than that, because I think the most exciting part is to have our three scientists telling us about their work. And as always happens, then Anne, in this case, maybe with the help of Daniele, will moderate the chat and the conversation. So colleagues, you are most welcome to put your question in the chat as they come to your mind, and they will be either grouped or answered one by one, depending on how many we have and the time we get. So I don't know who starts the presentation. Raphael, okay, the floor is yours. Please go ahead, and welcome again.
Thank you so much for the invitation. So yes, NanoBubble is an ERC project. We started just a year ago. We are now 26 people. That's composed of 9 academics, including the 4 PIs, and then 17 PhD, postdocs, and other research support staff. And as Angela just said, our aim is to better understand how, when, and why science fails to correct itself. So today, the seminar will be presented by 3 people, Frédéric Bourdignon, a linguist and bibliometrician, Y.J. Erden, a philosopher and NanoBubbles ethics rapporteur, and myself, a physicist. And we will take you on a journey from the origins of the project and the methods, and then some of the ethics and ethics challenges. And finally, we will give you some example of sub-project and the synergies that exist in this highly interdisciplinary project. I think that's one of the things you might be also interested in. So I need to actually share my screen. I haven't done that yet, so I should do this. So you can see it, yeah, all good. So where does this story of this project begin? So it begins in my experience as a physicist working in the field of nanosciences, of encountering problems. So in this field of bionano, which is at the interface between physics, chemistry, and biology. So it's already a very interdisciplinary field in itself. And so the first controversy I became involved in start with this 2004 paper. So in 2004, I was like a young postdoc in Liverpool. I had done my PhD in France, in Strasbourg, completed in 2002. And in 2004, I was in Liverpool and as a postdoc. And so this paper basically reports the formation of these particles that you can see here with these stripes of two different molecules, the red molecules, which are a bit shorter than the yellow molecules, and that organizes in this structure. And the reason why the authors thought that they organize in these structures is because of these images, which comes from scanning probe microscopy. And the problem is that in my interpretation, these images, these stripes that you can see in these images are actually an artifact of the technique. So they don't come from the actual structure of the particle. They are an artifact of scanning the sample, and it's a relatively well-known artifact for people who are familiar with this type of techniques. And it's a technique that I had used during my PhD. So what did I do in 2004? Basically, I did nothing. I was a postdoc at the time, and I had other priorities, and you know, I basically looked at this paper and thought, okay, I mean, that's kind of interesting, maybe a bit funny, but you know, let's move on. I was actually quite interested by the general topic of organization of molecules at the surface of nanoparticle, because I worked on similar topics with other types of molecules. But yeah, I did basically nothing at that time. Then in 2008, there was another paper. I mean, actually, in between, there were a number of other papers from this group on the properties and the structure of these particles. And in 2008, there was a paper that talked about the special properties of these particles to enter the cell, their special abilities to enter cells. And this is a topic that was very much of interest to me. And so we decided with members of my group to basically do something about that. And we done some experiments, some reanalysis of these images, and we published a paper, we submitted a paper with the title of Stripy Nanoparticle Revisited, and it was submitted in 2009. And then it's a long story that what happened between 2009 and 2012, but basically, it took 3 years to publish this revisited article, this Stripy Nanoparticles Revisited article. And so I thought that basically we needed better ways of opening critical discussion of scientific articles that wouldn't take 3 years during which, you know, many other papers were published and so on. So I started to blog and also use Twitter for scientific discussion. And then a lot of interesting things happened, and the controversy continued on various blogs, mine, but also others, on PubPeer, and so it kind of attracted a little bit of attention, and various papers were published. Some of those questions that were asked related to the science itself, like do these particles exist or not, but many were different, were more about, for example, whose job it is to address flawed peer review, or our blogs and media and social media, you know, which are great because, as I've said, they accelerate discussion, but they're also free from the control of formal peer review. Are they the right place to to discuss science and to hold scientific controversies, and to what extent or at which point does critical analysis become something more worrying and problematic, like bullying, basically. And so these controversies kind of continued, and at some point become to cool down a little bit. And I'm not actually sure to what extent we can say that science was corrected or not in this particular controversy. That can be open for discussion. But as this controversy was cooling down, I became involved in another one, which is the spherical nucleic acid controversy. And I will briefly present also this controversy. So it concerns a large body of work published by Chad Merkin in over 50 scientific articles in top journals from starting around 2006. The expression itself, spherical nucleic acid, was coined in 2012, so well after the first article. And what these objects, spherical nucleic acids, are, they are actually particles with some oligonucleotides, so DNA strands attached to those particles. And this body of work is the basis of several companies, scientific prizes, millions of dollars of research grants, cell biology research regions, advertised and sold worldwide for several years, as well as clinical trials. So what is the problem in my view? So to explain this, I need to spend just a minute or two to tell you something which is basically established knowledge for many years. So this is from a 1963 paper, for example. And this established knowledge is that nanoparticles enter cells, but that they end up in vesicles inside the cell. So basically, if you have a nanoparticle, this is like a cell here, you have a nanoparticle and it's going to enter the cells. But it is going to end up in a vesicle, like a little bag inside the cell, which is called an endosome. So this is the general methods whereby in a wide variety of normal situation, cells will take particulate objects, so particles, including nanoparticles. And so why is that a problem? Is because if you want to do things outside of these endosomes, so if you want to interact with whatever the cell is doing outside of the endosome, which is basically most of what the thing is doing, it's not happening in the endosomes, but in this compartment called the cytosol, or maybe in the nucleus, then you need first to escape endosomes. So let me come back to the spherical nucleic acids. So these 2006 articles reported that you could use this spherical nucleic acid, which at that time were called oligonucleotide modified gold nanoparticles, for intracellular gene regulation. And the problem is that in this article, there is absolutely nothing said about how the particles enter the cells, and if they enter by what was already known, as I've said, as a general mechanism, which is endocytosis, how they would escape the endosomes, which would be necessary for intracellular gene regulation, because gene regulation does not happen in the endosomes. So what happened after this 2006 paper is lots of promises, including some really big ones. So these materials would open the door for new possibilities in the study of gene function and nanotherapies. It could be used for transfection agents, for detecting mRNA in live cells. It could be used to tackle all sorts of disease, could positively impact tens of millions of people. And one aspect that particularly interested me was the fact that they commercialized this technology. The regions for, in particular, the region for detecting mRNA inside cells. I mean, I won't explain in details how this is supposed to work, but we have the same paradox, the same problem, which is that for those types of particles to detect mRNA inside cells, they first need to escape endosomes. And so a technology called SmartFlare was commercialized in 2013 to detect mRNA inside live cells. This was commercialized by a large multinational company and advertised to all cell biologists in the world. And that was interesting for me because one of the problems with replicating work, especially in a field like nanoscience or let's say, a nanoparticle, a field that uses nanoparticles or materials that would be made in the lab, is that if you fail to replicate, one of the questions that would be asked is, maybe you haven't actually prepared the materials in the right way or something like this. So here the actual particles were available commercially, so we could buy them and test them, do some experiments, and we did that. We did that as an open science project. So we published all of the data as we were going along, and we basically found that they did not report the presence or the level of mRNA inside cells, that these particles, like other nanoparticles, were confined in endosomes and basically degraded in those compartments which have a quite aggressive environment, because they are there to protect the cells from external threats. So when we published this data and when we started to put things online on this problem, we were contacted by a next application development specialist in the company that was actually selling these materials, confirming that he had worked for months basically on this product, trying to develop applications, and failed to detect mRNA levels, and basically reached the same conclusion, and he eventually left that company because his plus one, his management would not hear him basically. So it continued to be sold for a number of years, and in 2017 there was another article published by two Polish scientists who confirmed also what we had found using different approaches, different techniques, and eventually the company stopped selling this product. So in 2018, the commercialization stops. And of course, I'm giving a very brief summary. Many things happened in this controversy, many interactions with various scientists and so on. But one particular sort of memorable event was when I asked some, let's say, very polite, but obviously quite critical questions to Chad Merkin, so the authors of all of these papers, at an ACS national meeting in Boston, and that he basically interrupted me and called me a scientific terrorist and a scientific zealot. So that was quite shocking for me and for the audience. And really the question raised by those controversies, whether the first one, the stripy nanoparticles controversy, or the spherical nucleic acid ones, are mostly not about science. I mean, there are interesting scientific questions there, which I'm still kind of want to continue to work on, but there are many questions which are really not about science. And I started to realize that in part through my encounter with Marianne Noël, a sociologist in France, whom I met at the ACS national meeting in Boston in 2015. And then we continued the discussion over the years, and we applied to at the time I was still in the UK. So after my postdoc in Liverpool, I got a fellowship and then became lecturer and senior lecturer in Liverpool. And so I continued my discussion with Marianne, and then we applied together for funding from the French embassy to organize a seed meeting. So these seed meetings are aimed at promoting interactions between scientists in the UK and in France, which is an irony, given that now I'm back in France, and that due to Brexit I could not actually hold that ERC grant still in the UK now. But it was a very successful meeting, very interesting meeting. And two of the people who participated to this meeting, YJ Erden, who you will hear from in a few minutes, and Cyrus Modi, an historian of science and technology and one of the PIs of this project, participated in this meeting, as well as many other interesting colleagues who remain friends of the NanoBubbles project. And a few months later, we submitted, so between April 2019 and November 2019, we sort of grew the project, brought more expertise that was needed, and crystallized a plan, basically, that's going to be presented a little bit more details in the next few minutes. And then we submitted this ERC Synergy grant. So the grant focuses on 3 bubbles in nanoscience that in bio-nanoscience that we both want to contribute to and that we want to study. The protein corona that changes everything. This is the idea that nanoparticles, that proteins will absorb nanoparticles and modify their properties. And this kind of came up in 2007 and became a very important field, even though the absorption of proteins on surfaces and colloids or nanoparticles was something that was known already for a very long time. The fact that nanoparticles may penetrate and reach the cell, the interior of the cell, which I have already alluded to. And then the question of whether nanoparticles cross the blood-brain barrier, where lots of hopes, promises were made, especially in the early 2000s, about the fact that nanoparticles could, for example, deliver drugs to the brain. So I will now hand over to Fred so that she will be able to present some of the theoretical framework in science and technology studies that we are using and planning to use to address some of these questions. Fred, I'm stopping my sharing so you can share your screen as well. And the floor is yours.
Yes, thank you, Raphael. I think you are able to see my screen. Fine. So in order to identify the processes that spread and reproduce error and create these 3 bubbles, we will draw on the conceptual resources of science and technology studies, STS, and also on innovative digital methods in Scientometrics and text analysis. And I will say a word about that later. So let's start with STS, which I am by no means an expert on, but which I will briefly introduce to you. So in the 1970s, STS emerged. That was a new field of science and technology studies, combining history, sociology, philosophy, anthropology, and other disciplines. And the aim was to understand scientific knowledge making as a social practice. So this led to controversy studies, making apparent the social dimension of science. Controversies are indeed sites where scientists disagree as to whether particular experimental claims are correct, and where the actors deconstruct each other's claims. And then in the 2000s, agnotology offers new tools for understanding why and how some scientists and also firms promote ignorance. This includes Proctor's work, you may have heard of, about the tobacco industry, and in particular, the cigarette companies creating doubt about knowledge of cancer and the danger of tobacco. And in our project, in the NanoBubbles project, we aim and we know we need to go further and to identify processes that actually hamper correction. Another approach is what we call laboratory studies, that is the ethnographic account of social and embodied practices within the laboratory settings. So these approaches have given rise to several fundamental ideas, such as the fact that scientists rely on what we call tacit knowledge, that is knowledge that cannot be fully expressed in words, but needs to be transferred by learning concrete face-to-face skills to reproduce the experiments. Those ethnographic studies rooted in the 1970s are today no longer confined to laboratories, as scientists are actually co-present in many places. They don't interact only in the laboratory. So we propose, actually our experts in ethnography will propose a multi-sited ethnography and historical study that examines the variety of arenas including laboratories, but also journals, conferences, and so on, that are largely populated by scientists interacting with each other. And in nanobiology, conferences have been a crucial site for debate over bubble claims, often in parallel with debates on social media like Twitter or Reddit. And whereas conflicting evidence in the literature may be ignored or simply listed without consequence, opposing claims about nanobiology are raised in a very personalized manner at conferences, as Raphael has testified, both in front stage of presentations and discussion, but also in the backstage of conversations and at dinners and coffee breaks. Of course, in addition to laboratory and conferences, scientific publishings and mostly journals provides a crucial arena for scientific debate, including in nanobiology. And in nanobiology too, understanding communication patterns and their role in the reproduction of error and overstretched claims requires an analysis of how these journals have developed, the journals in nanobiology have developed, how they respond to error, how they respond to error correction and bubbles, and how they relate to new forms of debate and knowledge expression. So in response to what you know, maybe the replication crisis and concerns over research integrity and insufficient self-correction in research, the newly emerging field of meta-science studies the spread of questionable research practices, QRP, that are problems with statistics and also individual misconduct cases. In particular, STS makes us sensitive to the organizational context of research, to science as a social activity, science as a human activity. So this redirects the focus from individual misconduct or individual sloppiness to collective processes to explain the persistence of error and also the failures of self-correction. So to understand error correction and to understand failed error correction, we need to examine the work setting of scientists in research organizations, including power relations and productivist research condition. Also, nano research has suffered from breathtaking promises about expected scientific breakthroughs and technological potential. So technological promising has been analyzed in earlier STS work, in particular for hard nanotechnology, and expectations about technological futures become actually performative. It means translating into incitements to pursue specific avenues of research or innovation so as to convince funders and also mitigate the risk of hype and disappointment cycles. We know that well-pitched success stories help create large-scale initiatives, but it is also particularly interesting that claims about nano's potential are increasingly challenged from within nanobiology itself, raising important questions for us about how premises and hypes or are adjusted or are corrected. So to carry out our project, we also use digital methods, including Scientometrics and text analysis. We will build up large corpora of text. We have actually already started that are corpora with the content of scientific articles, but also tweets or comments on post-publication peer-reviewed platforms, also press articles, because they can mention retracted articles, for example. You know that more and more tools are being developed by computer scientists to carry out automatic screening of these scientific publications. And maybe you have heard of some developed by two of our team members, Cyril Labbé and Guillaume Cabanac, who have developed tools to detect unreliable or very odd results. For example, they have a tool to detect what they call tortured phrases. For example, when you read in an article colossal information instead of big data, or when you find counterfeit consciousness instead of artificial intelligence, well, it's a clue that you may be dealing with a plagiarized document based on bad translations. They also have developed tool to detect papers that have been completely or partially automatically generated. And we also want to develop tool to detect claims and also counterclaims. Claims sometimes in patents where actually claims are core to these types of documents. And we also would like to go beyond citation counting and study citations and understand why a scientific paper is cited, to back up a claim, to point out a different problem, to explain a methodological point, or, and we know this is very, very rare, to disagree with a claim. So new tools are becoming available to classify citations according to their polarity based on context, like, for example, Cite or Cite.aa, you can test online, where citations are classified according to their polarity in order to know whether the authors of a paper actually agree with the other study they cite, or if they disagree, if their own results are contradictory to previous studies. And for us, it is also a way to track claims and potential counterclaims. So as part of our approach and our commitment to correcting science, it is possible that our critical stance may cause harm, provoke offense or resentment, or could put reputations, theirs or ours, at risk. And so we give extra attention to ensure fair, respectful, and ethically sound approach. And I now give the floor to our ethics rapporteur, with whom we discuss the issues and also take advice. So let me unshare my screen. YJ, it's up to you.
Thank you. And I'll now share my screen. And of course, the obligatory, can you see? Excellent, thank you. So as you can see, we have lots of important and very good intentions in our project in order to achieve these to the best of our ability. Then, as Fred said, we need to think very carefully about the ethical foundations for our actions. So our aim is to ensure good, rigorous science through effective methods of correction, but this requires substantial ethical reflection, not just a kind of, minimal approach to the ethics as compliance, but rather what we see as essential is a rigorous and transparent ethical method. We do this in a number of ways. First, as Fred described, we called the ethics rapporteur in the project. It's a slightly unusual role in that I am an embedded project member, but I also take on what we've described as also described in the literature as meta responsibility. I'll explain that a bit in a moment. Just to say that this is not exactly what we were asked to do in the ethical assessment of our project proposal. We were asked to bring in an external ethics advisor, but instead we argued that an embedded approach would be much better for the project and generally, and I'll explain a little bit more about how we came to that conclusion. So for us, ethical engagement is a way of ensuring that each member of the project is actively thinking about the ethical implications of everything that we do. This is our methods, our practices, our aims, our ambitions, our outcomes. We do this with full discursive practice. We also have independent experts in our ethics advisory board. So my role as an ethics rapporteur, for instance, means that I engage in the close monitoring of the work that we do. I offer advice when it's welcome and when it's not, although it's mostly welcome, I'm pleased to say. We also explore ethical issues as they occur. We also think about ethical issues in terms of foresight. And that meta-responsibility I described, well, that is essentially my taking on the role to ensure that all members of the project have a certain level of responsibility for the ethical practice. So it's not that we have someone on the outside who is looking at what we do and encouraging us to think ethically, but rather each one of us starts from an ethics by design approach, i.e., how do we ensure that ethics is embedded at each step of the way? The way that we achieve this is to ensure that I'm not engaged personally in any empirical research, for example, anything that requires ethical approval or the gathering of data or interviewing subjects. All of that's overseen by the standard university ethics committees. Another way we achieve this is by not committing to or being dependent on any particular empirical outcome. So failure is also a worthy study for our project. As well as providing advice, I also give some training. I communicate with our independent EAB. I we co-wrote and edited a memorandum of understanding that everyone signed. This is our, if you like, contract to ethics, our commitment to ensuring that everything that we do takes into account the highest ethical standards. And I also write our ethics reports with the help of my colleagues. So what we did early on in the project last year was we started to think, okay, well, we thought about ethics from the grand scale of the project, the implications of our project for wider society, but what are we worried about? What are the things that keep us awake at night? And there were many. It's a very long list, which you can see in our report. But just to give you a sample, we worry about the attention given to ethics as a kind of tick box structure where people simply comply. We want to avoid that, but to do that, we need to interrogate different values. These include our own values, as well as the values of our individual countries, and as found in instruments like law, but also the values proposed and committed to by the European Commission. That's quite a complicated thing already, so we spend a lot of time discussing this. We also are concerned about how to treat people fairly and ethically. This includes those people that we scrutinize, whether it's to do with their work, their practices, their business practices, as Raphael mentioned. We're also concerned that we shouldn't become the integrity police, including on our own institutions. There are some risks there, not only for the people with whom we engage, but also for ourselves. We puzzle about this distinction between what it is to be a neutral or apparently neutral observer, as opposed to being an activist, as opposed to being an academic, and of course all the things that feature within that, such as the phenomenon of whistleblowing or the need to report fraud and how we assess something as fraudulent. And of course, when we're at a conference, we have to think about the different kinds of spaces, and I'll come back to that in a moment, but just to give you a vague sense, of course, a conference seems to some extent quite public, but there are, of course, some private spaces within that. People have private conversations they don't expect to be overheard, and so on. So our aim in this ethical reflection is to promote that ethical discussion. So we don't just engage with legal instruments as hoops to be jumped, but rather as methods to ensure ethics and good ethical practice that we critique, think about, and try to embed. One of the things that I do in my role is to help foster that sustained discussion and reflection, even on the topics that seem obvious or simple, or the topics where we think we're not going to reach consensus, because of course there's always value to be had in the perpetual discussion. There are a number of benefits to this. I think that this gives our project an edge in terms of ethical oversight. I am there in the project, in all the meetings, looking at all of the decision making and the struggles, and I'm an active participant in all of that. So if I have any doubts, then it's not simply a case of covering things up for the outside, but rather about inviting people in from the outside to talk with us about the things that we struggle with, including our EAB, but not only. I also have easy access to anything I need, any information that I need, and we can do this quite quickly. There's also really goodwill towards ethics in the project. I think that embedding this discursive approach means that people in the project, including new people who may not be familiar with ethical processes, they don't necessarily now think of it as something from the outside that's done to them, but rather something that they do, that they can participate in, where their values are also reflected and promoted. So we avoid that conflation with compliance or minimal oversight, that kind of lip service to ethics that we sometimes see in projects where ethics is not valued quite so highly. Of course, it is not an easy thing to do to be embedded in a project as an ethics rapporteur. It requires continuous reflection, not only that I ask of my colleagues, but that I ask of myself. I have my own biases, preferences, tendencies, and I am not immune to being absorbed in my own way of viewing the world. So to sustain that kind of necessary critical distance, we have to have those difficult conversations, even at the end of a meeting when we are tired and there are still things to reflect on. And that's not easy. In a way, if someone from the outside guides us, then we're sort of led by their own agenda, and their agenda is not led by ours. It also means that sometimes you have to give unwelcome advice or guidance, even and especially when values conflict. Luckily, as I say, all of my colleagues were committed to this from the very start of the project, so there has been a lot of open dialogue and willing, but it's still never easy to disagree on topics and to keep having to push through those disagreements to a specific project aim. It's also difficult to agree what is sufficient for monitoring and managing ethics. This is a problem that we see also in all kinds of ethical discourse, including in the evaluation of projects within the European Commission, which I've been participating in for many years now. But again, I think there is value in continuing along that path, even if you may not fully disagree, but you can reach at least some minimal consensus. And finally, we have to balance those project aims, as I said before, with those ethical aims. So if you want to see what this looks like, you can have a look at the first ethics report. In there, we detail the aim to embed an internal ethics rapporteur and the special dispensation that we were given. That was back in March last year. And then in June last year, we signed a consortium agreement, which included an aim to embed ethics by design approaches. As I say, that's to ensure that ethics is a consideration at every step of the project from the start to the end. We also list our ethical concerns and the discussion and some resolutions that arose from that early meeting in February last year, as well as our agreements and plans for next steps. Towards the end of last year, we reached an agreement also on social media data, and we adopted a guidance framework for the ethical use of social media data. This goes beyond simple compliance or data management. This is about how we think about the data from social media users as being something that's not simply there to be used, including by researchers. You'll also see there an outline of our consortium and ethics advisory board meetings. You can see some dates there from last year and this. And finally, that memorandum of understanding that I mentioned earlier, which is agreed and approved by members of the project and the EAB. And that took many sort of iterations, again, trying to capture the full range of values, concerns, and commitments that we as a project wanted to make. So our most recent activity, which will be detailed in our upcoming report, as well as our future plans. I can tell you just a few of these. So for example, in February this year, we had already had, well, how do I put this? Lots of new members had joined us. We expanded our synergy, and Fred's going to talk about that in a moment. And so in February, I met with all of our new members to see what their concerns were, to see, once they'd taken into consideration what we thought about ethics, whether they had other ideas, other concerns, whether they wanted to build on those. Some familiar topics came up, some new ones. You'll see here that we talked about this problem of witch hunting, which is a really not a great phrase, let's say, but it is common parlance. And how do we protect participants if we are trying to be quite critical of people's work? You'll also see that people are worried about this distinction between the public and the private, the difference between fraud and hype, and how we try to distinguish the different kinds of conference spaces. For instance, we had quite an extensive discussion about the fact that someone may present a paper and that may be considered a document or at least an outline of ongoing public work, which may not be the same as the data that comes from a panel discussion where people are testing ideas for the first time. Perhaps they don't expect to have to commit to the things that they share, but rather they expect that people will take it with a kind of generous interpretation of an off-the-cuff remark, and how we distinguish those kinds of data. We also had a workshop just last month on the topic of diversity and inclusivity. This was by an expert in the subject who came to talk to us about implicit bias and inequality and the impact on science and participants of these issues. They also described what's been done on these topics until now, which includes taking into account what works and what doesn't. It's very clear, for instance, that implicit bias training is not a silver bullet. That implicit bias is very complex, and that what it requires is something much more proactive. For example, these sorts of measurable goals and the cultivation of cultural curiosity, which I'm happy to discuss in the questions if anyone wants to know more about. We also have some plans for the coming year, as well as writing this next report. We're planning for a 2-day ethics training, critical thinking, and shared vocabulary discussion event. This will be January, February next year. We're also thinking about creating some ethics guidelines and frameworks for ourselves, which include some of those tricky issues where we think actually it's more than just one person deciding what's good to do. We need to have the full weight of the project, if you like, behind our decisions. So how do we deal with reporting errors in a particular case, for instance? What can we all reach consensus on that kind of topic? So I mentioned already that this involves synergy and with our new partners and our old. So this is a great time, I think, to pass over to Fred.
Thank you, YJ. So let's talk about Synergy. The project, is organized in 5 closely connected work packages, each involving all the PIs to guarantee maximum synergy. And well, this is us. So it has been 1 year since the project started. And to prepare this presentation, I asked all the members who have not been here in the project for a year from it. I asked them to send me a short description of their research activities so far and to tell me with whom they had collaborated. So I created this network of collaborations where nodes are actually members. The color around the node is standing for the official attachment to one of the 4 PIs. And the link between 2 members, 2 nodes, stands for the research topic these 2 members are working on. So you can see that the network is already very dense and shows how strong the synergies are already, and that not everything revolves around the 4 PIs. And at the top right corner, you can also see Zoe Touré, who is our project manager and is actually involved with everybody and engaged in many projects, and she's just keeping an eye on us. So I will now dive into this network to review some of the sub-projects that have been already initiated. And let's start with post-publication peer review. Those people here are working on. So as we said already, blog posts and comments are a rich source of information regarding the diffusion or the detection of errors in the literature. So the concept of web annotation with explicit machine readable links between annotations and the annotated web documents is emerging as an important approach to comment directly within the text of scientific publications. And in nanobiology, Raphael has been pioneering these non-conventional approaches to science communication via his blog, Twitter, and also per peer, and a tool dedicated to annotation, which is called Hypothesis. So people here are choosing articles relating to the three bubbles, and they read them carefully. They concentrate on the scientific language of these articles, the methodological rationale, and the logical coherence of the statements. And then they write and post, or will soon post, their comments, likely on per peer. There are also many people, of course, working on correction practices. And the annotation task will stimulate debate about crucial nanobio claims and how correction attempts are received. So these people here are currently investigating correction practices. What are different ways to correct knowledge claims? What new correction procedures are coming about? And moreover, corrections not only happen in the scientific literature, but correcting knowledge claims also occurs in the media, although perhaps not enough, and on Wikipedia or via channels, again, such as per peer. There is also some people working on claims and promises. I have already mentioned promises earlier, especially exaggerated promises. So several members of the team are working on this topic. For instance, Stefan and Candida have been collecting what they call future-related claims in nanotechnology, that are claims that include a specific year, for example, in 2010 or by 2010, or a time frame like within 2 decades. So the idea is to combine quantitative and qualitative methods to identify more of these claims and to compare these claims to actual developments in nanotechnology. And their idea is that the discrepancy between future-related claims and actual developments could be helpful to illustrate how certain claims have been hyped. Also, using documents published by or about companies, using also news articles and funding reports, we have Maud and Max who have planned to reconstruct how social and economical promises for a novel drug application impact research networks and the generation of a medical study. And also here another group started a periodical, that is a kind of journal which highlights articles about a particular topic. So I'm part of that group, and we are publishing a periodical about hype and overpromising in science. So we actually provide summaries of interesting articles with the dual goal of having interesting discussions within the group about this particular topic, and also to make an interesting collection for other scholars. So you can be new subscribers to our periodical. You can go online and subscribe to it, and you will be updated when we post new summaries. And there are also 3 people interested in conferences. So in order to study conferences, historical methods are not enough, because everyday practices are often not preserved in historical sources, especially practices relating to settings such as conferences. So they are rich in interpersonal interaction, and our experts will use ethnographic methods that are necessary to understand how conferences work and are experienced. And members of this, let's say, sub-project will accompany other members to the conferences they regularly attend in order to observe and experience contemporary real attempts to correct the scientific record. And obviously, this is linked to journals, laboratory, and firms, because correction practices in conferences are coordinated with journals, labs, and firms. Of course, we are interested in scientific publishing with those people working on that particular topic, because scientific publishing and journals, of course, provides a crucial arena for scientific debate, including in nanobiology. So the journal is both a gigantic publication infrastructure and a communication system that is increasingly questioned. The new business models like open access, for example, are emerging, and challenges are coming from alternative publication formats, such as preprint servers, and again, PubPeer and any other post-publication annotation venue. Journal articles, of course, remain tokens of recognition and achievement, but they are becoming less exclusively the locus of written communication. As I said, in nanobiology too, understanding the role of communication patterns and their role in the reproduction of error requires to analyze how journals have developed and how they handle the correction of errors. You know that journals are businesses, and business considerations may prevent them from correcting errors as much as they should. That's what the people here are working on, and sometimes even already in collaboration with publishers. So these were only examples we're working on so far, but we have many other projects, for example, working on negative results, the publication of negative results. There is also a part of the NanoBubble project dedicated to replications, also to the study of critical citations. We have, with the PhD student starting soon, we also would like to analyze retraction notices, and we plan to work on shared vocabulary and many others. So you can follow us on Twitter to be updated, or go to our website, subscribe to our newsletter, of course. I would like to thank you and thank the ERC for the funding of this project. Thank you.
Thanks to all of you. Yes, we clap hands for this synergetic presentation of our KPI, also representation of the fourth one, and a large team, which it was very nice to see the network analysis of the various nodes and collaborators. That's clearly very synergetic. I also noticed that Raphael, you're a little bit of interesting minority in the interdisciplinary outfit of the team, if I can say so. Very often we have complaints from people in social sciences and humanities to be added on to projects led by and defined in the question and method and so on by people in physics or engineering or life sciences. Here you clearly have been in the lead with your colleagues, and the social scientists seem to be the majority in the team, if I got it right. Of course, science and technology studies is a mixed field. People come from different disciplines, but anyhow, that's a very interesting outfit. Maybe you can tell us how this work and how you manage to conceptualize and be together in the definition of the methodologies in the team. But that would just be maybe my question just to get started. And then I think Anna is collecting some questions, so she will then take the lead in the question and answer session. And I invite again all our colleagues, listener, participants to put their question and comments in the chat so that we can. We have a good half an hour to do so, so I think we can have a good exchange. Raphael, would you pick up the challenge, or maybe one of your colleagues, and then we get started?
On this one, maybe I can start. Of course, Fred and YJ, welcome to add to it. Yeah, I mean, it's true that I'm in the minority, that the project grew from my experience in nanoscience, but then as I've tried to explain a bit with this trajectory and with meeting Marianne and then the workshop and so on, it grew mostly in the field of social sciences, where many of those questions really are, and it's a very exciting thing for me actually to be part of this group and to learn. And actually, I learned enormously just by meeting those colleagues first along the years and intensely during the writing of the project. So it's and then of course now it is continuing. I think it's both a great opportunity and it's clearly a challenge in lots of different ways as well. Well, it's a challenge because I need to learn some of this common language that was already mentioned, and common sort of expertise. And of course, I'm not going to become an expert in all of these different fields. We still thankfully have the right expert in the team. I think it's also a challenge because I'm representative of a larger group potentially, but I'm not representative. What I mean there is that I'm the only nanoscientist in the group, but of course there are many nanoscientists who don't agree with me on many topics. So I guess that again brings lots of ethical questions, and I can see YJ nodding. And so yeah, it is a good observation and one we have to navigate. But certainly one of the interesting things in the project. I don't know if I answered your comment.
Absolutely, thank you. And I think also this shows that if I may make a little add for ERC, the fact that ERC is one of the few scientific council in the world and the research council in the world that has an whole science approach, including all areas of science. In its remit, is one of the things that makes this kind of cooperation and cross-fertilization very possible and even most welcome. And so I don't know whether any other member of the team has comments, otherwise I will leave the floor to Anne for other questions.
Well,
no, so
no.
Anne, go ahead.
Then I'll go ahead. I just want to say thank you also from my side for the presentation and for joining us today. I've been really looking forward to the seminar. I wanted to ask also why, so of course it's in a sense it's your background, Raphael, but why the focus on nanoscience and why these particular 3 cases that you're looking at? It seems to me, but correct me if I'm wrong, that these are 3 cases where science in fact didn't manage to correct itself. Why are these 3 cases the most important? Why were they selected?
Yeah, so it does come from my experience, and I guess one related question is, what do we mean by bubbles, and to what extent there are bubbles, and to what extent they are erroneous, and it's quite complicated. And to answer this question, and I think the choice of these 3 bubbles is also because they represent different sort of categories of problems that we could address and that exist also in other fields, certainly. So, for example, I mean, one theme that maybe came back a couple of times in the presentation is this idea that there are facts or theories that have to be forgotten for these bubbles to grow, and so I think that's appears when I describe the spherical nucleic acid controversy, where we basically had to forget that it was well known the way nanoparticles enter cells for all of this to happen at the beginning. And that's also the case of the first in my opinion, again, it's one that can be questioned, and I'm sure would be questioned if there were other nanoscientists in the room, and maybe will be. I would say that's one of the debates about the protein corona bubble. So that's an interesting case to probe this. And it's quite difficult to do. And I think here the digital methods will help us, because one of the challenges that we have these very large body of work, and to follow claims before protein corona was coined, and also since, those digital methods would be very useful to analyze this large body of literature and see how those claims, those citations, which papers were cited, which papers were forgotten and then rediscovered, and so on, will be quite interesting. So this is one of the example. The one about entering into the cells is interesting. I mean, the same thing happened, but there are also some issues around, for example, commercialization, and that probably are less relevant to the protein corona. And I guess the blood-brain barrier is maybe one also where this issues of hype and promises is very interesting. So that these examples are to some extent a little bit arbitrary and linked to my experience or my interest, but to another extent, we hope that they contain some features that are a little bit universal, and that we will be able to draw conclusions that can apply elsewhere.
A follow-up question that I came to think about also when I was, because I was browsing around on your really interesting website yesterday, and I recommend everyone to go and have a look. And as I mentioned when we chatted before the seminar started, I watched one of your seminars and the presentation by Professor Murray. And it seems to me like what appeared to me in a question was, you were talking also about the correction of science, but isn't there a big failure in the peer review system if these articles were even managed to be published in the first place? I wonder if you could say a little bit about that.
I could say a very little bit, which would be yes. That would be like a very short answer. Yeah, I mean, there are huge failures in peer review, and yeah, I mean, this is something that is quite hard to study. I mean, we have a few ideas. One of our members, I mean, Marianne, whom I have mentioned already, has done, for example, interviews with editors and so on. And so studying kind of the mechanics of peer review system might be one approach to understand. I mean, these are really, I mean, it's very interesting to study this also because it's a system that is very much in flux, with new models of publication, new models of peer review, which are being experimented every day. So definitely big failures exist in peer review, and in some cases, like indeed in the Macchiarini case, with dramatic real world effects causing huge suffering on patients and so on. In other cases, it's less dramatic, and it's more of an academic question of how we manage this system of knowledge. But yeah, in some cases it is very dramatic, and I guess the spherical nucleic acid is possibly a little bit in the middle of these two. So I'm not too sure. I don't think it has caused huge suffering, but there were clinical trials which, in my personal views, are not based on sound science. At least some difficult questions have not been asked.
I think that one of the things that also surprised me was that for some of the examples that are described where the correction of science doesn't work, is that it seems so obvious that it should have been corrected. And so, to be honest, I was even a bit discouraged after looking into all these cases. And I was so how do you keep, because I know that one of the aims of NanoBubbles is also to try and help overcome some of these hindrances to the correction. And how positive are you that this can be done?
Yeah, this is a really hard question now. You asked me to jump to the conclusion. It's given me another 4 years. Yeah, oh, have I lost connection? Am I still
Welcome.
still
You're
live?
very
Yes.
well. Yes,
We
you're
hear you.
fine.
You can.
We can
Okay,
hear you.
thank you. For some reason, you all appear frozen on my screen, but I'm glad that you can still hear me. So, yeah, I mean, how hopeful we are. I mean, I don't know, and we are 26, as I've mentioned, so there might be a different sort of psychological attitudes to our chances of success. You know. Yeah, I don't really know. I mean, where I definitely agree with the premise of your question is that in my personal experience, there are certainly things that I consider obvious mistake, which not only made it for peer review, but which, when pointed out to editors and so on, were defended with a lot of energy, or rejected and so on. So in the first controversy, for example, there were claims that were literally based on zero data, just like a drawing in a figure, like a cartoon basically, but no data were included in the paper. And when this was pointed out to the Nature material editor, it was basically dismissed as not being important. So I don't know what the answer is, and I think that exactly to understand these kind of questions, we do need to look at, like, I would say one of the reasons for this project is precisely that I don't know how to answer these questions, and that some of the problems involve social sciences, the relation between editors and authors, the business aspects of scientific publishing, and I guess some of the hope lies in the sort of transformation of scientific publishing, but clearly there are lots of risk there as well. It could become worse instead of becoming better. So, yeah.
I'm just going to hand the microphone back to Angela for a question.
Yes. Well, as you were saying, you are focusing on your experience in the field of nano and nanobubbles, and you choose those 3 examples. And I was wondering, in your work, for example, when you analyze claims, where you analyze how claims are addressed, I don't know whether the question is more for Frederick or Raphael or others, you will choose among yourself. So are you also comparing with other controversies? There are many in science, as we know, in many areas of science. So are you, identifying some aspects of the controversies you are addressing, and the issue of correction, self-correction or non-correction, in this particular case with other ones? And the reason I'm asking is because it would be interesting to know whether you're making some comparison with other controversies to see whether there is something unique, or whether there are certain aspects that can be generalized with other fields.
I keep going. Oh yeah, do you want to go on, Fred? Oh.
You go ahead.
Okay. I would say that, yeah, this is definitely going to be interesting and important, that we focus on nanoscience, certainly as a starting point, partly because this is one of the strengths of the project, to have this integration of disciplines, to have nanoscientists, me and people working with me, working with social scientists in the team, and STS scholars and so on. So we start with this, but actually several members of the group have also experience studying other controversies, and so that's definitely going to be something that will happen, that will need to happen in a second step, to test whether whatever we find kind of extends, and how and what we can learn from these specific controversies compared to others. So yeah, I mean, the short answer is certainly that this will be needed and will happen.
Maybe I can briefly add something, because practically speaking, when it comes to automatically identify claims or promises and over promises in scientific publications, we need first to know what a claim or what a promise is and how it is expressed in a text. So at the very beginning, we will look for examples. We don't need to be to find examples within nanobiology or those three bubbles. We need to know how we can express a claim, what a claim is. Is it different whether it is in a scientific publication, in a patents, or in a news article? And when we know what a claim is or what a promise is, what words are used to express a promise, we can go further in the nanobiology field, look for those kind of claims in the field, and then check those claims against the three bubbles we have targeting and maybe generalize more afterwards.
Thank you so much for this. I'm going to jump to a question from the audience now, from one of my colleagues, and he's asking, is there a risk that the exponential growth of scientific output undermines or even invalidates the theory of sciences developed by Popper and Kuhn?
Shall I take this one as a resident philosopher? Actually, my colleague, another philosopher in the project, and I give this quite substantial thought that we're not just reflecting on the methods as they are specific to nanoscience, as Raphael pointed out, but even just the very idea of scientific certainty or the kinds of expectation of fact that comes from the public that funds science. So indeed, we can see that risk in the sense that there may be just too much material to fully test in the way that we would need to in order to ensure that science is rigorous. But we also see the possibility for a different approach to science in terms of our expectations. I think at the moment, science has been facing all kinds of backlash. If we think about the vaccine debates and concerns, for example, partly because there is a large tranche of the population who don't quite know what to do with all of the uncertainties that science contains. And this is the kind of stuff that Kuhn was pointing to, the necessary biases and preferences of scientists and how that leads us down certain paths. We don't think this has to be how do I say, like an insurmountable risk. It doesn't have to be something that it spells the end of science or anything like that. Far from it. What we think is that if there is more discussion about what science requires in terms of a reflection on bias and a reflection on the foundations for certainty and how we deal with risk in our everyday lives, then we could end up with something much more engaged with people's fears than we have currently. At the moment, we still have this kind of top-down, a scientist is going to tell us something, including about the coronavirus, for example, and that's going to feed into advice and people are going to follow it. We still have this expectation that that's going to be the process. And what I think we see is that doesn't always really capture the kind of sociological or philosophical aspects of knowledge creation. So yeah, I see the risks for sure, but we're not pessimistic. We're still optimistic that we can help to reframe some of those expectations as well as just the scientific practices themselves. Don't know if that answers the question. It's a big question.
Question indeed. I wanted to actually go back to something that you highlighted in your presentation, and it was that tension between being the neutral observer and then also being kind of the activist or the whistleblower. And I'm sure that's probably an ongoing debate that you will be having throughout the project, but I wondered if you wanted to talk a little bit more about that one, because I find that a very interesting kind of tension.
Yes, it's an excellent topic for discussion, and we've had many, and in the project we'll have many more. I mean, from my own position, I'm really disinclined to engage with the idea of neutrality, in the sense that I really don't see a possibility for a neutral position. I'm of the view that there is a standpoint that people occupy a space in the world, and this influences everything that they see and experience. So how do we manage that tension between wanting to offer some kind of objectivity and neutrality, because that's still a useful value in science, while nevertheless recognizing the necessity of our biases? I don't think there is a one size fits all answer for that. I think that it requires not only that we reflect on ourselves, but that people come in and tell us stuff. So what was really interesting about that workshop last month is we had this external expert come and look at the way that we work, so that they offered reflections on, neutrality and objectivity, not just hypothetically, but also in terms of our project, how we work together, what we talk about in meetings, the directions that we follow. And that can be, unsettling, but in all the best ways, I think. So I guess our role is to not only try to promote the importance of an objective view in science, but also to embrace the impossibility of neutrality to some extent. I think that's what Raphael was saying earlier when he acknowledges, here and frequently, well, I am one scientist in this debate and not everyone is going to agree with me. And it's really important that we recognize that in the project and think about what we do with that. Does that answer your question? Again, it was not a big question, but.
Yeah, and I wanted to thank you so much for that. And I wanted to then a follow-up question to you, Raphael, if I may, because I know, as you explained yourself also in your presentation, already when you were a postdoc, you started kind of engaging maybe in a little bit more activist or whistleblower role, and I was wondering what type of that's not an easy position to have either, and what kind of backlash have you felt in this regard?
Actually, I didn't really. So in 2000, well, I have faced backlash over the years, but I haven't really acted as a whistleblower when I was a postdoc. So when I was a postdoc, I saw some problems and I didn't really do much about it. So it was actually when I was a little bit more senior, although I didn't have yet a permanent academic position, that I started to take some more risks, we could say. I think it would be fair to say. But I can give many other examples from my experience and from talking with people and interacting with people, and I'm sure you probably have your own, that indeed there are the consequences very often are very bad for the whistleblowers. Actually, when I learned that this ERC grant was successful, I thought this is totally amazing. Also, one of the many reasons why this was totally amazing was that in a way, my experience of correcting science and being a whistleblower or at least challenging findings had led me to this position where I'm actually funded to do this kind of work. Whereas for most people, it ends very badly, especially if they are in a junior position when they take these risks. So this is definitely something that we think about, that raises ethical questions, and I think that this is something that relates also to policies around research integrity and organizational matters inside research institutions, on how they deal, and also journals and so on how they deal with complaints, how they support people, especially young people who might take the risk of asking questions and so on. And these are topics I'm obviously very interested in, and that are maybe in part related to the aims of the project. And I don't think they feature much explicitly in the grant proposal, but it might very well be that we have to say a few things about this as we go along. And Willem Afman, one of our members, one of our PIs, has also studied policies around research integrity. So it's an area where we also have a lot of expertise.
I will go to another question from our audience. do you think it would be pertinent to study the link between error and interest, scientific error and commercial interest?
I can take it, except if someone volunteers. It would be pertinent, but we have to focus a little bit. And I would say this is not, let's say, one of our priorities. And it might be also something that's been studied. So, I mean, in the what I would say is that this is about the generation of errors rather than error correction and error correction mechanisms and when they fail. And I think that's one of the originality of our project, is to focus on error correction. So it's a little bit on the edge, and of course we will touch it. We will necessarily touch on things on the edge, but it's not the main focus of the project.
And it's probably linked to what we are going to investigate about promises and other promises that are linked with the industry, for example, for some particular examples.
A follow-up question here from the same colleague. So do you think the old 1976 concept of champ scientifique, and I'm sorry for my poor pronunciation here, of Bourdieu could help understand this link and your work?
I mean, I'm not an expert on Boudoir, I'm afraid. I'm a philosopher of language by training, and I'm much more informed by people like Wittgenstein and Foucault than Boudoir. From what I understand, this is about the monopoly of scientific knowledge in the scientific domain. I mean, perhaps Michael can correct me if I'm wrong. And certainly that's something that we do think about, though perhaps not from the point of view of Boudoir. But I'm not even pronouncing it correctly. I'm aware of that. Forgive me, my French is horrific. If he wants to say more about it in the chat, I'm happy to respond to more specifically or ideas.
Well, it's Bourdieu, and I'm sure that Marianne, your sociologist in-house, knows about his work very closely. But you know, what we understand from the answer is that you are not using, at least explicitly, that kind of, let's say, paradigm, which is perfectly fine. There are many, I'm sure, and maybe it will give you the curiosity to explore whether it is relevant for the work you're doing. And I see that there is another question. From Nicoletta.
Yes, here. Can you comment on casting correction in a positive light, normalizing it, while at the same time not denigrating incorrect studies?
Yeah, I mean, I can say a couple of words on this. I think it's so we are currently, we have several post-publication peer reviews that we are working on and that we will shortly post on PubPeer. And this is really something we are thinking about a lot, actually. So that includes, we are thinking about the format of our post-publication peer review. So we want to emphasize the value of doing post-publication peer review and the fact that this is scholarly work that needs to be encouraged, that needs to be maybe cited. So that's kind of one aspect, I would say, of the answer. Of course, there is the issue of language, of being respectful of the work that we criticize, and so on. And then if I take we have also to think about what are the problems we are talking about, because there is a whole spectrum from, you know, minor disagreement, maybe scientific controversies where the issue is that we may disagree on some specific topics that needs more debate and so on, to things that are getting closer to fraud, to fabrication, to mass fabrication of computer-generated articles, as Guillaume and Cyril have been studying and detecting. So, of course, the type of comments that would respond to these different situations and the type of there is no point not denigrating an article that has been generated by a computer, although that doesn't mean you have to use denigrating language. But if you signal that an article has been written by a computer, well, certainly the authors are put on the spot. And actually, this issue about the author being put on the spot, or feeling that their professional self is being questioned, is something that that is unavoidable, I think. So you can be as polite as you want, and it can be in the context, and as respectful as you want. If you question a large body of work from a single author, for example, as as I've been doing in the past, because these are the papers I have stumbled on, these are the controversies I've been involved on, then necessarily the person whose work is being questioned will feel that their own professional self is being questioned, and this is very difficult to navigate. And I'm sure YJ wants to add something to this, because it's something that raises questions.
I do actually, because I think that one of the things that we're dealing with is the fact that scientific discourse, just as discourse in all disciplines, isn't always in good faith. I mean, we've all been to conferences where people, rather than ask questions, they demonstrate knowledge. They seek to, destabilize a conversation. People also do this in publishing. It's common also in philosophy. It's not the case that philosophers are committed only and always towards truth. They also have their own ambitions and aims and preferences and their ego at stake. I think that one of the things that's really tricky is to maintain that good faith engagement, even when we're engaged with people who may not be good faith actors, people who have other ambitions than purely scientific good. Our aim, especially our ethical aims, is simply not to perpetuate those sorts of negative spaces within science or other disciplines where the goal is to succeed at the expense of others. Our aim is to be considerate and positive, even if we are trying to show what happens when things go wrong. Because we want to have this positive outcome at the end. And if I may, actually, I think this leads quite nicely to this question about the SoCal affair in the questions. Do you mind if I move on to that? One of the things, so if people are not familiar with that, this is where an academic submitted a paper to a conference. It's kind of a nonsense paper, if you like, or at least it's not really what it ought to have been, and it was accepted. And they did this to try and show, well, look, this demonstrates that academia can be broken, that academics deal in jargon and nonsense terminology. I have to admit, I don't view the experiment like this. I appreciate that people can trick other people with jargon and nonsense terminology, and also with the unfamiliar. But as far as I'm concerned, that can also be representative of something more profound, right? And this is that human beings try to understand each other. So I'm a Wittgensteinian by training, and I'm really interested in the idea of a language game. And what happens in the academic discourse, or the academic language games, is that we come from different disciplines, or even the same discipline with different terminology. We try to understand each other, which means a certain amount of linguistic or meaning generosity. And so the people that accept papers at conferences, they may be reviewing papers outside of their expertise, who are nevertheless trying not to gatekeep, trying not to say, well, because I don't understand this, it must be wrong, right? So one of the things our project is doing is looking at how to navigate all of this without being prescriptive, without being gatekeepers, without saying what you're saying is wrong because your terminology is different, and trying instead to get to the heart of the problem. Is there an error, and how do we identify this? And we want to do this in more robust ways than simply, individual bias or preference or training in a particular terminology or approach. So as I say, I think all of this demonstrates a kind of positive reaction, as opposed to trying to call people out or shame them for what they do or don't know, or what language they do or don't use. I think that's absolutely essential to doing this well and doing it ethically.
Thank you. Well, we are getting more and more, into passionate and interesting conversation, and I think actually this is a great closing, since the timing is now, well, I know for some physicists time doesn't exist, but according to our clock it does, so it's time to close. But I think that what your conversation, and of course the last part, very explicitly address the fact that NanoBubbles is trying to engage with something which is part of science in any field. That is, we make error. To understand, to improve our knowledge, we can only make errors. I mean, it's impossible not to. This is part of just trying to gain knowledge. So there is nothing wrong about the fact that there are errors in the pursuit of knowledge in any field. And then the question is, well, why error comes? Is this intentional or unintentional? This is one of the points you were making. Yes, looking for integrity in science is about uncovering the, let's say, intentional fakes or frauds or behavior and whatever. And whether intentional or non-intentional, what are the mechanisms, methodologies, language, context, peer review, extended peer review, whatever that we have detected and to try to correct. Now, coming back to one of the questions, I don't know whether your project will support, expand, or drop Hopper's belief in falsification in science or otherwise. That will be an interesting question for you, as well as discovering for you maybe. But I think it's so important that in a context where we are, where of course there are many sources of assessment, many expectations. We were of course making the case of COVID, but there are many others. Expectations are important elements that you are addressing, and it's true that sometimes people, either with good intention to save the world, to find the things that are good for humanity, might feel too much pressed to claim that yes, I'm discovering something that can save us or help us. And of course, there are also pressures, surely, on scientists in all fields to go for that. But then the backbone is speak truth to power, including within science. So, in spite of all the pressure, how we remain genuine to the fact that if there is a mistake, we will accept and try to correct it, rather than cover it and pretend either that mistake cannot happen or that mistake are left there without correction. So thanks to all of you for your engagement and for the endeavor. I'm sure that we will hear more about the NanoBubbles in the future when your research is more advanced. And so thanks again, and thanks of course to Anne and Daniele for the organization, and Aras for making possible our virtual encounter and for participation. So thanks to all very much.
Thank you.
Bye.
Thank you so much.
Thank you very much.